Hello, good day to you. We are looking at Chapter 4, Basic Algebra. So on NCLS, you have already viewed a video on the founder of algebra, and this is the mathematician that you have seen, and why the word algebra is as it is. It is from this Arabic word algebra. So we are going to look at why we are going to learn algebra. So these are the objectives of this unit, this topic. Alright, and then why is algebra useful? Well, one of its usefulness is so that we can represent this big, okay, not really big, this number with many decimal places with a simple letter, and it can save a lot of time. Alright, now let me go to the examples of algebra. We are going to look at page 3. Please turn to page 3. So in algebra, we use letters to represent numbers and variables. And as you can see, this blank which starts with the letter V is for the word variable. A variable, V-A-R-I-A-B-L-E, represents an unknown value, and this can be any number. So algebraic expression involves number and letters that are connected with operation symbols. So we are now looking at an algebraic expression. So these are examples like 9x minus 7, m times n, a divided by b. So in the term 3x, the constant 3 is the number before x. It is 3 times of x, 3x. This 3 is known as the coefficient. My apologies. Let me try that again. The coefficient. This is an E. Coefficient of the term 3x. The coefficient of the term 3x. 3, okay? Okay, so now. So let me look at what kind of expression we can get with the different operations. The first one is addition, second one is subtraction, multiplication, or we even have powers and then division. And then a combination of operation. Mrs. Liao is going to use these letters X, Y, and Z for all the examples here. X, Y, and Z for all the examples here. If I see 4 different numbers, then I'm going to add in the letter W. Okay, now, the question example has 6 minus 5 equals to 1. If I want to use algebra, this can mean x minus y is equals to z. I write my z this way, so that the 2 and the z can be differentiated. Okay? This is just an example for you to see. My 2 is this way, my z is that way. Okay, continuing. Now I see multiplication as the operation. So I'm still going to use x, y, and z, but in this case, the x value and the y value are different from the previous question. So these are just symbols, yeah? X times y equals to y times x. Just like 3 times 5 equals to 5 times 3 is equals to 15. I will use z to represent 15 in this case. Now let's move on. Let's move on, yes. I'm going to use x and y for this example. So x to represent 3, x times itself, which is x squared, which is equals to y. In this case, y is representing 9. Then 3 times 3 times 3 is 3 cubed. I'm going to write x times x times x is x cubed, which is equals to another number different from 9. Now I'm going to use z. So z in this case is representing 27. Now we have 24 divided by 3 is equals to 8. I am going to use x, y, and z. X divided by y is equals to z. And some pupils may ask, Mrs. Liao, can I write this as a fraction? And sure, you can. X over y is equals to z. Alright, and the last one. Wow, aren't we glad that we have letters that we can use to represent such long string of decimal digits, decimal places. So now I'm going to use x times y over z is equals to w. Apologies, I didn't change my color. You can also write this as x y over z equals to w. Okay? Alright. Has the use of algebra simplified the mathematical workings? Of course. What other examples could you think of using letters to represent algebra? Formulas like area of triangle is equals to, do you remember what's area of triangle? Let area be A, half times let base be B, and perpendicular height be H. Area of triangle is half B H. Alright, let's try this next part. Henry is 9 years old. Find his age after 3 years. Easy. 9 plus 3 is 12 years old. And find his age 10 years later. 9 plus 10 is 19 years old. And then next one, T. So it should be 9 plus T years old. Easy. Let's move on. Next page is page 4. More algebra representing real life examples with algebra letters. And they are also known as variables. Okay, the price of a cup is $5 and the price of the plate is $12. Find the total price of 3 cups and 2 plates. So Mrs. Liao is going to write total price is going to be 3 times 5 and 2 times 12. 15 plus 24, now I add my units, $39. Part B, n cups. It will be n times 5, n groups of 5, plus m groups of 12, which is going to be, n times 5 is 5n, bracket, sorry, plus 12m. Bracket with a dollar sign in front. What did I just found? I found the total price. Pardon my handwriting, but I'm sure you understand what I'm writing. Now let's move on. Question 3. Express the following statements algebraically. A. Multiply the sum of C and D by U. So Mrs. Liao is going to look. I want to find the sum of C and D first. And then multiply by U. So A, sum of C and D. C and D multiply by U. We can rewrite this as U times C plus D, so that we can save writing the multiplication sign by placing the U in front of the whole brackets. Okay, next. Subtract the quotient. Quotient is the result of division. quotient of A divided by B from the cube of V. Wow, so many things that we need to do. Okay, now let us read. Quotient of A divided by B, A divided by B. We need to subtract this from cube of V. So my answer is going to be subtract from the cube of V my quotient of A divided by B. This is my answer for part B. Okay? If you don't understand, you can ask your teacher to explain it to you again. Now Mrs. Liao is going to move on to like terms and unlike terms. You have learned this briefly in primary school. Nonetheless, let us look at this again. In an algebraic expression, parts separated by the plus and minus signs are called... Yes, you may have heard from your primary school teacher, these are called terms. So in an expression, the terms are, we have 5y. Let me write in red to emphasize this. And then you look at the x term, not forgetting the negative sign. This is negative 8x. Very important, the negative sign. And then the last term with no variable, no letter, is called a constant term because it will always be a fixed number, 3. Alright, this is a constant term. Okay, now let's move on. Coefficient. Remember, we talked about this earlier on. If the term has a letter, the number right before the letter is the coefficient. So what is the term? 5y coefficient is 5. What about the next one? The term is negative 8x, so then the coefficient is negative 8. And then the coefficient of the constant term is the constant itself, which is 3. Aha! So, we are going to look at the next part. When two terms have identical variable parts, they are called like terms. Identical variable parts. When two terms have different variable parts, they are known as unlike terms. So, example 2a and 4a are like terms because they contain the unknown a. And then, we have a and b being unlike terms because they don't have any identical variable parts. Okay, so now, what shall we do to the like and unlike terms? Oh, but first let us look at this activity 2. Perhaps you can try this on your own before you listen to me. You can pause this video, and once you have tried this, you can continue the video to review the answer. Alright, so column A, we have C. Column B, we have C cubed. Are they like or unlike terms? Yes, these terms are unlike terms. Continuing. Next part, we have AB squared, and this is 2AB squared. Are they like or unlike terms? They are like terms. And then the next one. Very obvious, you can see that this is a letter C. Over there are no letter C. So they are unlike terms. And then over here we have A squared, B squared. However, the other side we have A squared, B cubed. Cube and square are not the same thing. So they are unlike terms. And then the next part we have A squared over B power 4. This one is A squared over B power 4. Aha! Tricky, but they are like terms. And the last one, what do you think? 1 over B power 4? 1 over B squared? Are they the same or not the same? They are not the same, so they are unlike terms. Let's try the next part. In this expression, negative 9mn plus n minus 6 state the number of terms in the expression 3. terms. Coefficient of n is positive 1. Yes, mathematicians don't write the number 1. 1 is taken as just, 1 times n is just taken as n, so they have left out 1. So this is coefficient of n is 1. What about coefficient of mn? Tricky. Don't forget your negative sign. Answer is negative 9. And the constant term is negative 6. The term without any variable. Without any variable. Yes, teachers like to use cursive because we want to write it fast. So please get used to writing cursive. Okay, now we are going to use different color pens. I'm going to use different color highlighter to group the like terms. I'm going to start with this u square. 5u square. Where is the other u square? Over here. Is that all? I think so. Moving on to u. Yes, not me, you. Haha, lame joke. U, 4 over 3u, negative 3u. Yes, they're all of the same type. Any more like terms? Now let us use turquoise. I see PQ and negative PQ. And I think that's about it. Ah, Mrs. Liao nearly got tricked. Oh, yes, this one. PQ. 8 times Q times P is the same as 8 times P times Q. My goodness. I nearly got tricked by this question. Yes. Alright, so here we go. 3 types of like terms. 3 groups of like terms. And then we have one constant term that's left alone. All by itself. Okay. Let's move on. Nearing the end, page 6. Right. Simplifying algebraic expressions. In algebra, complex mathematical statements are simplified. Through this, what would seem like a complex mathematical statement could be reduced to a simple one. Yes, now we are going to do simplification. But before that, we are going to do translation. Translate English language to math symbols. Okay, come, let's take a look. The cost of an apple is A. Now I understand. A is representing the cost of an apple. And the cost of a pear is 3 times as much. I think it's 3 times as much as the apple. The total cost of 6 apples and twice as many numbers of pear is simply, okay, we are looking at 6 apples. So that will be 6 times of A. And if I have 6 apples, twice the number of pear will be 12 pears. But how much is 1 pear? 1 pear is 3 times as much as the apple, so this is 3A. Get it? 3 times as much as the apple, the cost of a pear is 3A. Twice of 6 is 12, 12 times 3A. Can we simplify? Now let's simplify. 6A plus 36A gives us 42A. And we are done. Now let's continue with simplification of these operations, addition and subtraction of linear expressions. Come now, let's take a look. We are going to remember our negative numbers, how we dealt with negative numbers. Okay, so this is a good revision for the previous topics. Okay, come. Over here. Why is the answer negative x? Because we are going to get, let's squeeze here, 2 plus 5 is 7x. Minus 8x gives us negative x. Revision for negative numbers. And then next one, 2a squared plus 8a squared gives us 10a squared. If you thought of this before me, well done. Oh, next part is to test us whether we are clear with our like and unlike terms. So over here, 2x squared, maybe I should rewrite this to help you see. 2x squared minus x squared, they are like terms, so I can put them together. Plus 4y cubed will give me x squared plus 4y cubed. We are done. Okay, what about the next one? Next one, it seems like I have the x squared term. Anything else x squared? No? Then we take a look. This is yx squared. Well, mathematicians like to be systematic, so it is better for us to write them in alphabetical order. I'm gonna write plus 5x squared y, then plus 7y squared. Apparently, they are all unlike terms. They are not the same as each other. So there's nothing for me to do except to arrange this alphabetically. Yeah, okay. Next one. Are they like or unlike terms? There are unlike terms. So there's nothing for me to do. Done. Next one. Let me take a look at the variable. I see x y squared. And this is x y squared. So it's basically 2xy squared plus 3/5 xy squared. So I'm thinking in my head, 2 plus 3/5 gives me 2 and 3/5. Not forgetting x y squared. Mathematicians using algebra, we like to write it as an improper fraction, so that we are clear that the xy is with the numerator, and this is a fraction, not 2 times 3/5. So a mixed number may have that misunderstanding, whereas an improper fraction is very clear, that 13 times x times y squared divided by 5. This is 2 and 3/5 is 2 plus 3/5, but some may mistaken this to be 2 times 3/5 if written in the algebraic form. So this is preferred to the mixed number in algebra. Alright? Okay, next part. This is going to be interesting. We are going to look at the variable first. I see y squared over x. Then this will be half y squared over x minus 3y squared over x. If you can't really understand what I'm talking about, if I rewrite this as half times y squared over x minus 3 times y squared over x, perhaps it's clearer to you. Then now we have to remember our negative numbers. Half minus 3 is negative 2, and a half times y squared over x. And like I've said earlier, I prefer this to be a improper fraction. It will be negative 5y squared over x. Wow, not easy this one. I hope you can understand. If you are not too clear, please go to your teacher and clarify that in class. Now, let's take a look. Haha, I know this question wants to trick me. I must look carefully for the like terms. I see x, y squared, z. The next one shows x, y squared, t. Haha. But then I won't be tricked by the t. So now let's look at the next one. I see x, y squared, z. So there you go. These two are like terms. And we are going to group them together. 3 minus 2 is simply 1. So I have 1 x x y square z plus 5 x y square t. This is the answer to the last part. Alright? Okay. Let's move on. And we have this last part where we can substitute in values so that we can find the actual price of the sum of the fruits. So after an algebraic expression has been simplified, you may substitute it with a number to obtain an exact value. So remember the example on 6 apples and twice as many number of pears. Now if the cost of one apple is 40 cents, how much will the whole set of fruits cost? I remember we have 42a. Let's do some working. 42a, substituting a. Oh, this is too unacceptable. Let me rewrite this again. When a is 40 cents, 0.4, let me use 0.4, then 42a is going to be 42. I will use substitution. A is replaced by 0.4, just like in a basketball match when a player needs a substitution, you change the player to another one. In this case, you change A to be 0.4 and you get 16.8. So this will be $16.80, which we will always write it as $16.80 with a dot sign. And we are done. Oh, great. Homework time. Have a good holiday after you finish your homework, alright? Mrs. Liao is going to give these questions as homework. 7, 8, 10, 11, 12, 13, and 14 as optional. Have a good holiday. Thank you and goodbye.